back, and we're going to go through our final lesson of Unit 3, which is quadratic expressions. Our overall big learning goals: students will be able to interpret and solve questions related to quadratic relations, and you've met these learning goals if you know how to create and solve an equation that involves binomial expressions, and we can extend that to trinomials that can be factored. Just a quick review, this here is what you're going to be using when you go into some problems related to factoring as well as expanding. This here is taken from the EQAO website. This is the formula sheet for grade 9 academic. These are things that you should know. Specifically for this lesson, we'll be using the surface area formula for the cylinder as well as the volume. And we'll also be looking at a square, which could technically be related to a rectangle. So this is our last unit. Our application problems is the focus, and specifically we expect to solve quadratic relations and interpret solutions with respect to corresponding relations and solve problems that involve quadratic relations. Here's the first question. And I encourage you to always pause at the start of each question before I do the solutions. Give it a try before you see the solutions. And I make this will probably look a little bit easier than it actually is because I've got a lot more practice. I truly believe that the more you practice, the better you'll become at doing word problems. Suppose the radius of a cylinder is x plus 2 and the height is 3x. Write a simplified expression for the volume of a cylinder. Well, the volume for a cylinder is equal to pi r squared h, and where we've got pi r squared is the area of that circle, and the height is going to be, well, just the height, so the volume will be represented by this. And in this case, we've got r is equal to x plus 2, and h is equal to 3x. And what we're going to do is we're going to substitute an x plus 2 and 3x into this equation and expand and simplify. Volume is equal to pi. Well, we could also expand this a little bit further before we put this in, but let's try it here. X plus 2 squared times 3x. I'm going to expand this x plus 2 squared first to make my life easier. I'm going to rewrite it with the 3x out front. 3x pi times x plus 2 squared is x squared plus 4x plus 4. I'm going to now multiply through by the 3x plus pi. Volume is equal to 3x squared will then turn into x cubed. And actually what I should do is I usually want to keep the numbers out front, and technically pi is a number, but we represent it as a symbol because it never ends. So it's what we call a rational number. 3 pi cubed, 3 times 4 is 12, so this is going to turn into plus 12 pi, and we've got the x times the x, which is x squared. 3 pi x times the 4 turns into plus 12 pi x. And this is as far as we could go. You could argue that maybe you want to turn the pi into a number, and that would become 9 point something, 9.42 probably. But really, this is fine to leave it as is because pi is a number, and this is as exact as you can get. Moving on to the next part of this question, it says, write a simplified expression for the surface area of the cylinder. Well, surface area, coming from that formula sheet, would be 2 pi r squared plus, in this case, 2 pi r times h. And again, we already know that r is equal to x plus 2 and h is equal to 3x. So all we have to do is take those numbers, expressions, substitute them in, and expand. And I'm going to use what I know from the previous example to help me out here because I already know what r squared is. So in this case, surface area is equal to 2 pi, and r squared was going to be x squared plus 4x plus 4. And I've got this plus 2 pi r, which is x plus 2 times 3x. And so I can simplify this stuff here into something else. So I'm going to expand through here, which is equal to 2 pi x squared plus 8 pi x. 2 pi times 4 plus 8 pi. And then I'm going to expand these things here, plus, I'm going to try and do it in one go. 2 times x is 2 pi times x is 2 pi x times 3x. This is maybe going to be a little bit too much to do, but if you're good, maybe you can still do it. Maybe what I'll do is I'll combine these two right now. That's technically 6 pi x. So it's 6 pi x times this x plus 2, so that's going to become 6 pi x squared. And 6 pi x times a 2 turns into plus 12 pi x. And now it becomes a job of collecting like terms. I can collect this 6 pi x squared and this 2 pi x squared. That will turn into 8 pi x squared. That's done with the x squared. We'll look at the x's. I got this 8 pi x and this 12 pi x. If I combine those, that turns into plus 20 pi x. And I've got this number at the end, which is just plus 8 pi. And we've gone as far as we can go with this example. Here's example, or I guess question number 2. The area of a rectangle is defined by 6x squared plus 13x minus 8. Express the area in factored form. So it already tells us that we're factoring. Look for numbers which can divide out the 6, the 13, and the 8. There aren't any. So what I'm going to do is I'm going to start to factor, and this is a complex trinomial. So I multiply this a value, which is 6, times 8 value. So I'm looking for two numbers that multiply to minus 48 and add to minus 13, and those two numbers are not 6 and 8, 4 and 12, no, 3 and 16, yes. So 3 and 16, which one is going to be negative? Well, it would have to be this one's negative, the bigger number is positive because this is positive. So now what I can start to do is area equals, now I don't know whether this is going to be 6 or if it's going to be broken into 2 and 3. But if I look at these numbers, it looks like I'm probably going to divide this one by 3. And so that would turn into negative 1. So I'm going to put 3x. And then in the other bracket, it's going to be 2x. And then this is going to be the minus 1, because the minus 3 will go, turning into the minus 1 goes into the other brackets. And then I'm going to divide this 16 by 2. That turns to 8. So that plus 8 comes over here. And the reason why this works is 2 times 8 will be the 16. And the 3 times the minus 1 is minus 3. 16 plus minus 3 is going to be the 13x that we're looking for. So we have now created a factored form for the area. Create a simplified expression for the perimeter of the rectangle. Well, perimeter is equal to 2 times length plus width. So now we're going into question number B. And we can consider these as being length and width. And I'm going to think that this is going to be the length. So let L be the length, which is 3x plus 8, and the width be equal to 2x minus 1. We're going to take these numbers and we're going to solve them, substitute them into this perimeter formula. So perimeter is equal to 2 times length plus width. So in this case, 3x plus 8 plus width, which is 2x minus 1. I'm going to combine like terms or collect like terms. Parameter is equal to 2 bracket. The 3 plus the 2 is 5x. The 8 plus the minus 1 is going to be 8 minus 1, which is plus 7. Now we're going to multiply through by this 2. Parameter is equal to 10x plus 14. Okay, so moving on to our final question. Currently, a square garden has an area equal to 4x squared plus 20x plus 25. If the sides both increase by 1, what is the increase in the area? So this will require us to most likely factor this, and I can't factor anything out from the 4, the 20, and the 25. This is a perfect square, so what I'm going to do is I'm going to factor it as though it was. So this is 2x squared, so I put the brackets, plus 20x plus 5 squared. So area can confirm that 2 times 5 is 10, times 2 is 20, so this is a perfect square. This is 2x plus 5 squared. So if we increased the length by 1, the new area, we'll call that new A, new area, is going to be equal to 2x plus 6 squared. We can expand this to become, well, we maybe use FOIL, 2x plus 6 times 2x plus 6. This is equal to 4x squared. 2x times 6 is plus 12x plus 12x plus 6 times 6 is plus 36. Simplify. 4x squared plus 24x plus 36. And how we answered the question, it says what is the increase in area? So what we should be doing is we should take this expression here and subtract the original expression. For the sake of speeding up the time, I've created a new slide, and this here is the new area. And this one over here is the old area, or the original area. And so how much did it increase by? What is the increase in the area? It's going to be the new area minus the old. So we're going to use the simplification, 4x squared minus 4x squared. That's going to be gone. The 24x minus 20 is going to be 4x. And now we've got 36 minus 25, which is going to be 11. So what it tells us is that by increasing one length, the lengths by 1 unit, that the increase in area is 4x plus 11. There's so many more questions that you could do. This is just touching the tip of the iceberg. And just like everything, math is not a spectator sport. I think it made it look fairly simple, straightforward. But again, math takes a lot of practice, and knowing those formulas, knowing your multiplication tables is something which is going to help you a lot, because then you can see the connections. At this point, I would expect you're going to make yourselves better at solving application problems by reviewing the application problems from the assigned homework from the last six lessons, and complete Chapter 5 review and the Chapter 5 practice test. Again, math is not a spectator sport. Keep doing your work, and thanks for watching.